Okay. Hi, everybody. My name is Jason. I'm Technical Service Manager here with Leary Company. Today, I'm going to give you some training and a tutorial on our Monet user interface, basically our gluing and detection software. All right. That was the job setup menu in the upper right corner of the home screen. Just below that, we have this icon that kind of looks like a graph. In fact, we do call that our graphs and LED screen. So if I go into the graphs and LED screen, I have these 5 main production charts. Sometimes they're utilized by the end user, sometimes they're not. Some customers may have their own kind of collection service where they're already collecting data information, but we do provide some local data within the controller itself. So we can actually look at total pieces per hour that have been running on the machine, and it does toggle back a full 24 hours. Okay, so you can see there's 2 charts here for pieces per hour. I can hit the check mark to leave this graph, and then I can go into the next graph, which is rejects per hour. This tells me the total number of failed cartons each hour. So you can see we've been running pretty clean, pretty good so far today. And that also goes back 24 hours. I can hit the check mark to leave that. So you notice I can go into each one of these graphs and I can hit the check mark to leave, or I can actually just go into a graph. This particular graph shows me just this hour. So over the last hour, how many failures did I have from each gluing and detection station? So I can see my 8 gluing and detection stations, hot melt gluing and detection. And this graph, again, would just show us the total number of failures that we accumulated within the last hour. Again, I can hit the check mark to leave this graph, or what I was going to show you is I can just continue hitting the arrow, and it'll just kind of take me around through all the graphs. So now I'm at pieces per hour, 24 hours. Then I'm at uptime minutes per hour. So the uptime minutes per hour, the top of this graph should be 60. And what this graph is showing me, behind the scenes in the system setup menu, we have a base target that we can program on how many pieces per hour should the machine be producing. So we can set this 1,000 pieces per hour target behind the scenes in the system menu. And what this graph then references or shows us is how many minutes out of each hour were we able to keep the machine running at least this rate, 1,000 pieces per hour. All right. So that also has a 24-hour graph. And then the next graph is total rejects per hour. So again, this just shows me the total number of failures each hour. It's a 24-hour graph. And I basically gone through all of them. So you can continue hitting the arrow on the graphs menu once you enter one of the graphs, and it'll just toggle you through all 5 of these production graphs. That might not be real important to you, but at the bottom of this graphs, the reason we call this the graphs and LED screen is at the bottom of this screen, there is what we call an LED page. And the LED screen, when you open it up, basically shows us all of the inputs and outputs of the Leary controller. Okay, so I can basically see all the valve outputs on this 4th row or this 4th bank labeled LEDs 4. It shows me all my valve hold outputs, all my valve spike outputs. And if I were to manually purge a valve here at the bottom, I would see that output as well. So we have a few different colors for the indicator, the LED indicator. White means there's no output or input. Yellow means pulsing. So with the machine running, kind of like what you're seeing here with the simulation, you're seeing a lot of yellow LEDs, which would be normal because all of these inputs and outputs are pulsing on and off with the product running through the machine. LEDs 3, these are all my pattern LEDs. So these are all my hot melt detection sensors, 1 through 8. As you can see, those are yellow and those are pulsing. Okay. My 2 triggers, trigger 1 and 2, those are also pulsing with the product running through the machine. If I were to stop the machine for just a moment, and I were to have the trigger, something stopped underneath the trigger. So if I were to stop the machine and have a carton or a substrate underneath the trigger causing a constant output, you could see the LED turn green. So green is a continuous or constant output. Yellow is pulsing. And if I move the carton away from the trigger, you can see it goes white. Then I have no signal from the trigger now. All right. So the important ones are triggers, patterns, and valves. So we got trigger and pattern inputs, and we got valve outputs. We also, on this bank of LEDs 1, we could see our encoder signals. So again, encoder A is kind of in a spot where it's our encoders have a pulses per revolution, and depending on the position of the encoder wheel, we might have a solid green light, or we might have just a white LED, meaning no signal. But once the encoder starts moving, the encoder wheel spins, we should always see the encoders be yellow because they're pulsing continuously as the revolution of the encoder wheel. The run output LED, that's an output signal from the controller, not really being utilized by you at the moment. We have a reject trigger LED, a compression LED. Neither of these are really being utilized by you. The lamp LED is a beacon light indicator for telling us when there's a failure. The beacon lamp will always be on if the master alarm is turned off. So if I turn this alarm off in the top right corner, you can see the lamp LED went away, so the light went off. And then at the bottom, if the system is powered on, you'll always see a solid LED for the software enable, just basically telling us the system is on. Any questions on either the graphs or the LED screen?
Can you explain the valve hold versus a valve spike? I don't know. What
sure. Within your application, you guys actually do not use a valve spike. I know it shows up here on my simulator, but on your actual application, you do not actually use a valve spike. You actually have you actually only have the valve hold. Keith, can you mute yourself, please?
Sorry.
Yep. The valve spike, so when we normally activate a glue valve, we actually use two voltage signals. We use a what we call a high time spike voltage, and that's usually a very, very short duration to get the valve to open as soon as possible. And as soon as that valve is open, we no longer require that higher voltage, so we drop down to what's called a hold voltage. So on your application, we actually, your hot melt applicators, your hot melt valves actually do not require a spike duration. So our standard spike voltage signal is 48 volts, which you do not use. We actually turn that value, it's a duration value, milliseconds. We actually set that to 0 milliseconds for your hot melt applicators because they do not require a spike voltage. Your hold voltage that we set up on your valve driver board, your valve driver cards, are 24 volts. So basically, we are just sending the 24 volt hold signal to the valves to activate them. We are not utilizing the spike. So on your application, you would only see the LEDs light up for the hold and not the spike. If you were to manually purge a glue valve, you would see the glue valve purge LED light up. And that's if you had a remote purge box that has the green buttons on it. That allows you to kind of remotely purge any individual glue valve, or if you were to actually purge through the software on the purge icon on the gluing and detection station. Does that answer your question?
It does. Thank you.
Okay. Any other questions on the graphs or the LEDs? The LEDs are probably what's most important to kind of understand and know where to find them. They really help with troubleshooting. If we have a possibly damaged cable, you know, sometimes we could still see a sensor light up when we put something under it, but we don't know that that signal we created actually made it back to the Leary controller. There could be a broken wire or a conductor within the cable. And what this screen allows us to see is when I put something underneath trigger 1 and I see the little LED light up on the physical sensor, I can ensure that that signal is actually making it to the Leary controller. Okay. All right. So I'm going to back up out of the LED screen. Now I'm back in the graphs. And just for informational purposes, this this production information, these production graphs or charts, we can actually record into a TXT file, and we can provide a TXT printout report via a USB key. So we can actually print this report to a USB key per day, shift, or job, whatever frequency the end user prefers to have this report. But basically, it contains all of the production information that is gathered throughout these 5 production charts.